So thank you all. Yes, I'm Jordi Mon. I'm an SPMM in GitLab. I'm in London, and yeah, I'm going to talk about actually the transition. We're not yet there. We're in the transition to become a purely microservices oriented or service-oriented architecture company. But the fun thing is that for those of you that you're not aware of GitLab, we are very, although I'm aware that there's enough people here that know about the product at least, we're a very peculiar company in the sense that we're completely open, so you can check the transition on our decisions towards that type of architecture if we eventually go finally for a full-on service-oriented architecture through the issues, because they are all public. All of our roadmap is public. You can collaborate, chip in, and so on. But first, I would like to tell you that I'm a bit sick today, so I'd like to apologize. I know that saying so in the context of the coronavirus spread out is like at least controversial, but I'd rather be honest because I'm not feeling at all very well. In fact, probably just after the talk, I'll leave to the hotel, which is pretty close. But if you have any questions, just save them, because I'll be back later in the booth we have just around the corner. But it's funny, I bring it up. Thomas told me not to bring it up, not to scare anyone. I know it's not anything related to coronavirus, don't worry. But I was reading about it yesterday, or trying to read, because, well, just as Thomas mentioned about DevSecOps, which I committed, and I think I didn't even mention it throughout the talk. If you go to the online media, social media, about the spread out of the coronavirus, it's difficult to navigate. It's all a mess, it's all hype, in this case, hysteria, and so on. But I did find one article that had a train of thought that was very parallel to the principles that I want to put through in this talk. So I thought it would be actually interesting. It was actually Tyler Cowen, the economist, had an article in Bloomberg, and what I'm referring to is a thread by an epidemiologist that commented on that. And he said that despite how counterintuitive it might seem, the coronavirus epidemic was a great example of the advantages and not the cons of globalization. So I'll read a bit. Again, I'm a bit thick-minded today, and oops, where's the okay? So this idea sounded counterintuitive to me. It's like, well, initially, globalized world is like fertile ground for an epidemic to spread out. And yes, it's true. But what he says is that all the nodes, if we think about a network and the world being a network, and all the nodes, maybe the cities or the airports, are much better prepared to counter an offensive that is inevitable in a way. So just like in the security world, 100% security is impossible. What we're trying to achieve is that each one of the service attacks and all the potential vulnerabilities have the best tools at hand to counter it. And he's saying, yeah, I mean, there has been many illnesses like this spread out throughout ages, so this is not new. Besides, all of those nodes, so for example, has the coronavirus reached Vienna? Oh, God, thank you. Well, I'll just bring it now. All those nodes know about previous contagions. Apparently, there was one really massive one in the 60s in the Middle East, and they've learned about it, okay? Not only that, but all those nodes are interconnected. Right now, the most advanced medicine or treatment that is in the process, it's being tested, well, actually not tested, but developed in Gilead by a company called Gilead in the US that actually had that treatment designed for Ebola in Africa years ago. It didn't work out, but now apparently it's one of the best suited for this thing. And in the Bay Area in San Francisco, they are trying to get better samples that came from Wuhan, from the origin of the source of the epidemic. And they're using CRISPR, which is a Spanish technology, to implement better those testings. So in a way, he's saying that through these values of globalization, so deep specialization, so each one of those specialists working together in coordination, common languages, in this case he's referring to English. He says that if the first studies from China did not come out in English, this would have taken a way much bigger time for that. And the cross-fertilization of different specialists has made, which would be the 3 pillars for him of globalization, at least in science, has made the world a better place to counter epidemics like this. So I thought these 3 values are very in parallel with what I'm trying to say, well, the idea, the thesis that I'm trying to put, that shifting left in a microservices architecture is actually the securest and fastest way, or the fastest way to keeping your code secure. Another fun fact of this is that I realized that some scientists, the most specialists in epidemics, in pathologies, and biology, knew about the breakout, and I'll finish with this, about coronavirus very early, like even before it broke out the news, because obviously it's their work. And they opened a Slack channel, which is pretty new for them, which they called the Wuhan Climb. And I loved it, honestly. That's the name of the Slack channel, which apparently is congregating like the greatest minds in epidemiology and pathology and so on. I just thought it was incredible. So basically, before the explosion of all the digital touch points that companies or the marketplace is full of, the main architecture was monolithic, right? This is just a copy of the virus that is just messing up my stomach right now. Monolithic architecture would sound good to the ears of security people initially because it has few entry points. Also, not all of those entry points are considered attack surface because they wouldn't allow for requests to come in. And at the same time, these entry points would request all the permissions of each of the requests, and once inside the application, the in-app processes and networking is much safer and so on. So initially, a monolithic architecture, although a monster for reasons that I'll explain right now, from a security standpoint is much better. I will define a monolithic architecture, by the way, as one that comes from one code base to one binary, right? That's the problem with it. Every time you want to build it and compile it, you will have to run through the whole code base, despite of the amount of change that you have applied to it. So that's the not so appealing part to it, but security people don't really care about that, right? So this would be the traditional way in which security would apply to a typical monolithic architecture software development lifecycle, right? In which the developer commits a change, despite the amount of change that will trigger the build process. Then the deployment and so on. And the first security check will just get, by the time this fella is already moving on to another task, and he's completely ignored the context of that change probably, and it just in a way comes a bit too late. To counter that, I mean, it's dynamic, so to counter that, interactive application security testing was developed, but then you have to instrument your application really well, and still it requires a working app eventually compiled and gone through all that to actually work. So it's still not, whoops, how's it going? Okay. It's still not like the ideal fast process, because the problem is that we all know this, and sorry, I didn't want to use buzzwords, in this case, this sort of like buzz sentence, but it's true. Software has in the world. I mean, just after monolithic architecture became like the paradigm of the architectures, the primitives became available to all of us. By primitives, I mean networking, storing, and computing. They were all over the place, in cloud, in the edge, in our smart devices, in IoT, and even in embedded devices without an IP. And most importantly, all the software and firmware in those devices can be now updated every now and then, like over the air. I believe, like, I'm not a big car fan, I haven't owned one in years, but Teslas have to stop every now and then to update their firmware, if I'm not wrong. So that's amazing. And that, eventually, I think that is a medium to an end, because the end is this. And it is good that we all acknowledge, albeit how terrible it is, that the power driving the shift in architectures and even in security, which follows, is that customer experience is eating the world. So Software is not there just to be there. It is there to actually enhance a transaction. Maybe it's just a service delivery. Maybe it's just support. Maybe it's even awareness or brand. So we must acknowledge that the reality is that the force behind the change is this one. And when software is already there, you just have to acknowledge that the problems manifest through the medium. In this case, it's software, which is everywhere. So in a context in which touch points are now supply side of the market and demand side of the market, the touch points between them is all mostly a two-dimensional pixel-powered interface. That makes competition really fierce because there's no way to communicate complex ideas through, or there is, but it's difficult. And it's also an interface which you can change very fast. I mean, this is again the owner of the sentence, Mark Andreessen, the owner the guy that came up with software as eaten the world, says that, well, I mean, the unit of measure of change of businesses through customer experience would be the speeding up of the release cycle, which again, and going into our initial point, does not link very well with monolithic architectures. So given this panorama, software design and architecture had a huge incentive to change, right? So this is given this panorama, the incentives were laid out there for monoliths to change, actually, into more service-oriented architectures. They have proven better to respond to these changes, that's all. But the thing is that they come with trade-offs, obviously. So in response to this shifting trend of going to service-oriented microservices, the industry or the infrastructure industry came up with the cloud, basically. The edge might be just a version of it, or which has this different this basic components. So the appeal of microservices is understandable now that we have that infrastructure over there. And it's already provided. The provision is easier. The cognitive load is much smaller. You can actually have your development team focused on smaller services, and therefore transmitting that knowledge is much easier. And each service has its own build process, and it's easier, usually much simpler and easier to automate. So those might be initially technical requirements that fit in well to the shortening of the development life cycle. But it has also challenges, fragmentation, data explosion, siloed teams, potentially, operational issues, or long-ass mean time to recovery. So in a way, there's also been a shift in the paradigm from monolith and customized environments to the cloud and microservices, in the way that when you build your monolithic application, you would call the code of a library to compose and complete the code of your application, while now frameworks, orchestration rather, behave like frameworks in a way that they will have the upper hand, and they will call the app code that you have designed as a developer as monoliths called libraries. So in a way, although there's interesting stuff about networking and security between the pods and the containers, the goal of this talk is more to analyze how developers can secure the content and the manifests of those containers to deliver it faster. So that's at the core idea that sits at what we call in GitLab shifting left, which is basically, well, to provide the application level development the right security tools at the right time, right? So when you shift left and you look to how the development tool market and the development tool chain and landscape looks like, it looks a little bit cluttered right now. If one wants to deliver a software, a service-oriented architecture from the idea, from the first phase, you will really need to have to connect a lot of points, and not only connect them, but keep them updated, And every time each one of those every time each pair of those that is connected has an update, then you will need to check, and you probably need to devote a person for the tooling. For the security landscape, it's basically the same. I mean, if you understand the software development lifecycle through those phases, which is arguable, but it's also acceptable that it's reasonable, you will find that the landscape looks pretty cluttered in a way. So the proposal that we do in a way, or shifting left, what it really means, it means three things. We're actually suggesting a cultural change, and again, it's not our product, but it's our philosophy. GitLab, as I mentioned before, it's a very peculiar company, not only because it works in the open, like I mentioned before, any one of you can comment, influence the roadmap or whatever, but also, for example, we are all remote and so on, fine, nothing special about it, but we also extremely dog food. So the product is built with the product. We only use GitLab to build GitLab. So we extremely dog food our own features, our own feature flags, or the stuff behind the feature flags, and our beta programs and so on. So this is what we do actually. We refuse to do MVPs, which is ideally like the minimum viable product. Right? We don't even do MVF, so minimum viable features, which would translate to feature branches. We only do MVCs, which would be actually task branches, so short-lived branches. We're talking about hours that would add the minimum value to, in this case, the user. So this is a cultural shift that we suggest would improve the building of secure software. It's also about the tooling itself. So we think that the cluttered landscape that we presented before does not, well, generates the challenges that I've mentioned before, mainly and principally silo teams. We think that tooling should enforce that changing culture and that whole holistic vision of the development of the DevOps cycle, if you wish, because it allows for every team member in security, development, operations to see everything that matters in real time. So it's visibility across all the DevOps cycle. Also, you'll find the information in the appropriate place to take place, and allows for concurrent working, so it's much more efficient, serialized way of working, and there's no handoffs. Ideally, if you have only one tool that covers all the life cycle, there's only stages in between, but the data model is the same from ideation to deployment. And for security and compliance, it's already built in. So the code quality, the scanners, they're all run ideally automatically inside the same process, which is only one. You don't have to jump from one to another. You don't have to convert data models, etc. So this is this is what it looks like for any given developer in GitLab. Again, not only the users, but rather GitLab programmers. That would represent the task branch that I mentioned before. So any given change would commit immediately. Again, taking into account that we're in the transition to move into microservices, or at least service-oriented architecture. So the amount of code, not only the amount of code committed is small because of the task branches, but also the amount of code that one's code base has is also smaller. So you're making the life of the developers much easier. And therefore, they can take care of security from the initial, because, as I mentioned, we're trying to empower them in the way that they are also the initiators of the vulnerabilities. The problem is that they don't really know until it's too late. So if you empower them in the sense that you allow them to automate stuff, like every time you commit a change, it triggers a pipeline that will run all these scanners immediately. So we're talking about code quality, running against code climate, container scanners, licensing, in case the dependencies have different types of licenses, static, and then building that into, or actually shouldn't be building, but creating a mimic of the production environment in which finally that change is going to take place in what we call the review app, allows us then to apply dynamic and other validation and QA testing, all in the same place, all before it even merges to the actual code base. So again, it is shifting left, it is moving left to the first phases of the code development, all these security measures that will not be definitely 100%, will not make your software 100% secure, but it definitely will make your mean time to recovery much shorter. So yeah, basically what the new lifecycle, you remember my first or the second slide of the monolithic application, now what we have is a shorter feedback loop in which the developer commits, triggers that pipeline that we've shown before. The review app will show a mimic of production. Testing could be there. So for security people, they would love not to be involved in this part. So for them, they can have a bird's eye view of all the complete process. It keeps their mind more outward than inward now that they have this checks inside. So, I mean, ideally, bugs go through and vulnerabilities go through, but ideally not so much now that every single commit, every single code check has gone through this. And obviously, through iteration, this tests and scans get better. And it gives them also the systemic understanding of what the whole, because it's all centralized in one place, of what the whole software development lifecycle means. So yeah, going back to my 3 ideas initially that I got from that coronavirus article, I think that they map really well with the benefits of shifting left, which are basically, we all speak the same language. If you're working on the same platform with this type of culture, you would not need to context switch or even change the data model. Each one of those stages will provide a report that is immediately actionable, so you will be able not only to understand the vulnerability or what went wrong, but actually take action immediately. And it's got compliance and security built in the way that permissions can be managed, and obviously you can have the appropriate person with the appropriate permissions working on the appropriate bug or fixing. So yeah, basically that's it. As I said before, thanks for your time, and I'm sorry I've been so sluggish. I'm a bit under the weather. And if you have questions, I'd rather have them later. You have us outside, and that's all. Thanks a lot.